Hi, everybody. We are here in the second part of section 2.2. So this makes section 2.2 part 2. And we are going to look at finding limits algebraically. So in the first part of this section, we looked at finding limits by using tables with different values, seeing what happens to the y values or the function values as we get the x values really close to some number. Okay, so that was our idea of finding a limit. We looked at finding limits graphically. So on a graph, can we trace along and see where the limit's going to be? Now here in this part, we are going to focus on finding limits algebraically. So we're going to be working with the functions directly. And there are four main properties or tricks that we're going to use here for doing this. And the first one of those is direct substitution. So this says, for a polynomial or rational function f of x, if x equals c is in the domain of f of x, then we'll see what happens. But first, let's clarify what this means a little bit here. X equals c being in the domain of f of x, that means that our function is not undefined at x equals c. There is actually a value associated with that. And we're looking at our polynomial or rational function here. We can plug in x equals c because it is in the domain. And so it turns out that then our limit as x approaches c of f of x is just going to equal f of c. Okay, so whatever that function value is, that's going to be the value of your limit in this case. So for example, we've got ourselves a nice little rational function here. Our f of x in this case is 3x plus 5 over 2x squared minus 4. All right. And we are taking the limit as x approaches -3. Now, you'll notice that sure, there are some places where this function would not be defined. There's a few things that get excluded from the domain on account of that denominator, but x equals -3 is not one of those spots, okay? X equals -3 is actually in the domain of this rational function. So if we want to find the limit, we just get to plug in x equals -3. Okay, and that's exactly what we do. Plug it in just like normal, just like you were finding the function value, because that is what we're doing. Okay, and we get -9 plus 5 over 2 times 9 minus 4. So that would be -4 over 14. And we would get -2/7. And so that is the value of that limit, okay? As the x values approach x equals -3, the function values of this rational function are all going to be approaching -2/7. Okay, so the overarching idea here is if you can plug in the x value in your limit, just plug it in and that'll give you the limit value. All right, but that also begs the question, what if x equals c is not in the domain of our function? Because this is pretty nice. If it is in the domain, we just plug that x value in. But of course, we're going to get trickier cases than that, where x equals c is not in the domain. And we'll see what to do with those in the next video.